yet another episode of Cloud Native Live, this time focusing on edge computing. We've been talking about edge for a while, and today we have a special guest, I guess, a new person that's joined Platform 9,
Yeah,
Samsher Ansari,
yeah.
and I'm excited to have him join us today. My name is Kamesh Pemaraju. I am the head of product marketing here at Platform 9, and I welcome you all joining us from wherever you are. Good morning, good afternoon, good evening. And why don't we just get started with a little introduction from our special guests here, Samsher Ansari? Do you want to quickly talk about yourself and where you come from, and then we'll dive into the topic for today?
Sure. So, hi guys. My name is Shamsher Ansari. I'm based out of Pune. Prior to joining Platform 9, I was in VMware working mostly on edge computing stuff for almost close to 2 years. And we actually built edge optimized runtime, which comes under approximately 50 to 100 MB in size. So, just to deploy those Kubernetes applications on edge computing location. Prior to VMware, I was in Red Hat, where I was working completely on the open source service mesh side. Um, and then I was a release manager for 1.9 Istio version. I was also a user experience working group maintainer for Istio service mesh for almost more than a year, I believe. Yeah, so that's it. That's all about
That's
me.
awesome. Awesome. Lots of great experience in open source,
Yeah,
Kubernetes, Edge. So you're the perfect guy. And first of all, welcome to Platform 9.
thank you. Thank
Uh,
you so much.
we are excited to have you on board and help us with our edge computing initiatives here at Platform 9.
Yep.
So can you talk about your role here at Platform 9 real quick? I know your official title is technical product manager.
Right.
What does that involve? What do you do?
So I joined Platform 9 as a technical product manager. Basically, my responsibility is to define the strategy and roadmap for building new products,
Mhm.
specifically for Edge and and a little bit of on the monitoring side. So I'm completely focused right now on a couple of things, but my previous focus was on mostly on the edge side, and
Mhm.
here in Platform 9 I'm focusing on monitoring, edge computing, and something which is going to be very excited, and we'll announce that soon, but I'm not going to expose that right now. So yeah, that's the exciting stuff that I'm working on. I closely work with a design team, engineering team, and basically the product team to collaborate and build the product that will actually add a value to the customer, right?
Got it. Awesome. Looking forward to working with you more, Samshare. For today, let's kind of dive into the topic. Edge computing is all the rage. Everybody's talking about it.
Yeah.
Lots of use cases out there. At Platform 9, we ourselves had a couple of use cases we talked about in the past,
Yeah.
specifically around retail, edge computing in the store, edge computing in 5G. What is your definition? I mean, there everybody you talk to has a different definition of
That's
edge,
correct. That's
right? I mean, edge like a tiny little sensor that's sitting in some warehouse somewhere? Is it a full rack of servers?
right.
What is it, and where does it exist? Where does it live?
Yeah. So I think the edge has been existence for a long time, but there are different definition for edge. What I understand edge is, it's basically a kind of computing environment where the data is generated, processed, and stored, right? So let me give an example of the simplest example that I can give, which will be understandable by everyone, is your mobile phone, right? So you
Mhm.
take a picture. That means the data is generated, the photo is generated. You actually go and edit that picture, add multiple filters to look smarter or beautiful, and
Mhm.
then that edited picture will be stored on your device, right? So
Yeah.
taking picture will be data is generated, editing will be processed, and then that picture will be stored on your mobile device. So that's the basic of what edge computing is, that anybody can understand, right?
Mhm.
If you talk about enterprises or retail or maybe like telco, it will be different for that, right? So for
Mhm.
example, if I give an example of telco, right? So we all have been using mobile phone. We all have been calling our relatives, friends, and talking to them, right? But how do telco process this data, right? So the data is generated from our mobile phone. It goes to a tower, a cell tower, or in technical terms, it's called as radio access network, that process your wireless communication, and then it sends back to a core network, right?
Mhm.
So the data is generated from your mobile phone, and it's near to you, right? So cell tower is
Mhm.
located everywhere on, like, on top of the building, or at and anywhere near that you live, right?
Mhm.
So the signal is generated, it sends back to a cell tower or radio access network where it has been processed, right? And then you get connected to your friends and family,
Yeah.
right?
Yeah.
So that's how in the technical term it is, and that's how
Yeah.
the edge is all
So
about.
here it's interesting because you mentioned, in my view, right, you have
Hmm.
edge, far edge, which is my phone. My phone is where I am at. This is
Right,
really my device.
right,
And then you mentioned the RAN tower, or the tower, the cell tower,
right.
which technically is also edge because there are
Yeah,
hundreds, thousands of these, especially in the 5G world.
right.
I guess there are hundreds of thousands of these towers everywhere.
Exactly.
And then you also mentioned core.
Yeah,
I guess there are multiple core locations too,
exactly.
right? They're all distributed. One common theme amongst all of these quote unquote deployments or usages is
Mhm.
that they're all distributed, correct?
Right,
They're everywhere,
right.
thousands, hundreds, dozens of them. Is
Exactly.
that a defining characteristic of edge? Is that there is compute in a lot of locations, and data is generated in all of them
Yeah,
in one some shape, way, shape, or form, correct?
right. That's correct. That's correct.
Okay. So how do you distinguish then? What do you do differently in each of these locations? And we one of the key themes for this
Mm.
live stream was when you have scale, when you have distributed scale,
Right.
tens and thousands of these locations,
Yeah.
how do you even manage your applications? How do you even manage the infrastructure? The phone, of course, is something that is in my hand, but in the
Right.
enterprise situation,
Right.
right, in a retail store or in a RAN tower, I'm assuming there's some sort of a compute, a server box or
Yeah.
something.
Yeah.
And now all of a sudden you have thousands of these
Right.
everywhere.
Yeah.
And it's not like you have technical administrators running around trying to fix stuff.
Exactly.
So I guess this is a big question mark. How do you deal with such a distributed scale, and how do you manage applications? How do you manage reliability? How do you
Yeah.
manage SLAs?
So I think it's a big problem in edge computing. So prior to edge, everything was in cloud, right? So
Hmm.
it was managed by maybe a Google Cloud, AWS, or Azure, or some
Yeah.
cloud provider, right? So the data is generated from our devices, it's sent back to a cloud, and they take care of all the hardware, software, everything, right? We don't have to worry about what they are generating, what they are manipulating, what they are changing and processing, right? But now, due to edge, the nature of these computing resources have been distributed across different locations, right?
Hmm.
So, like, I gave an example of cell tower, right? So it's near to
Yeah.
you, right? But
Hmm.
managing and handling all of these devices are critical and complex, because you have to manually send the person to inspect what happened there,
Mm.
install that device, right?
Yeah.
And then if something goes wrong, you have to go send a person, physical person, to actually go and repair those devices. and
Mhm.
and the telco case is really complex, but if you think about retail also, you really have to send somebody to fix those devices, because retail store don't have IT guy. They If they
Yeah.
are hiring IT guy, then they have to spend a lot of money on them, and they're not aware what the IT guy is doing, so it's complex for them to understand their processes and everything. so
Hmm.
so so the edge computing, basically what it brings is solving all of these problems of maintenance, installation, provisioning, upgrade, without this person sending to that location and solving that problem, right?
Yeah.
How do we
Is
do
that
that?
how it is done, though? So the question is, what? So it sounds like people do send people
Yeah.
to these various locations.
Right.
Let's talk about a specific example. I know you built an edge computing environment at VMware, for example,
Hmm.
right? These are edge. So how was it done before? I guess there is a solution today which kind of makes all of this seamless, easier, centrally
Yeah.
manageable. But
Yeah.
before this existed, what
Mhm.
what were people doing? Walk us through an example.
Yeah. So, for example, I worked on one of the project. Maybe I would say in 2014.
Hmm.
It was a long time, almost 9-10 years ago,
Hmm.
uh, and it's still live. It's called trackschoolbus.com.
Mm.
Uh, what we built is we actually installed one hardware device on different buses. So the client came to us. They had a requirement that they wanted to track their school buses, and they had 100 buses at that time,
Mm-hmm.
right? And they wanted to track these buses. They wanted to send parents a notification that the bus is near your house. You have to send your child. When the bus will be reach near your location, you will get notification on your mobile, right?
Yeah.
And they can also see everything on their mobile phone, where the bus is currently, where they are moving, whether they have reached the school or not. So all of these can be tracked with a small hardware device. The hardware device was kind of it's like your credit card, right? It's that small
Mm-hmm.
that it can fit in your pocket,
Mm-hmm.
right? So we install that hardware device on that specific
Mm.
bus, right? And then we configure it to connect it through a cell tower and network. So we install a SIM card inside it, which will actually use a nearby
Mm-hmm.
network, and then it will send you a location on a centralized management server, where we identify, okay, this bus is moving from this specific point to that specific point, right? So at that time there were no Kubernetes. I think
Mm.
Kubernetes was born in 2014 and
Yeah.
15. That time we didn't even know about
Yeah.
Kubernetes. So we had to do it all by ourselves, right?
Mm.
And while testing this, we actually installed this hardware device on each buses. So we had to physically send a person,
Mm-hmm.
go and install that hardware
In all
device
the
on
100
that
buses.
specific.
In all
Yes,
the
that's
100
correct.
buses. Okay.
That's correct. That's
And
correct.
it's just, is
And
it just
now,
the hardware, this little device you mentioned? What about the software that's running on it? Is
yeah.
it running something on the device?
Yes, so it's basically a embedded C application that was running on that small hardware device.
Okay.
It used to actually generate a TCP packet, which that TCP packet will have location information, device information, and on which specific bus this hardware device has been installed. So there are lots of information in that TCP packet.
Mm-hmm.
That TCP packet used to send on a centralized IP address,
Yeah.
kind of like a management server, where we used to extract that TCP packet, extract different information from that packet,
Mm-hmm.
and then store it into Postgres database, right? So that time it was 100 buses,
Mm.
but now I saw that trackschoolbus.com website,
Mm.
and they now install these devices on 40,000 buses right now.
Wow.
So the scale has huge,
Mm.
right? And I'm not sure if they are using Kubernetes or not,
Mm-hmm.
because it was too long and I'm not in contact
Yeah.
with them. But I was the one who started that project. I got the opportunity to lead that project, starting from configuring that hardware
Mm.
device to installing that to some, and then we actually deployed that on AWS at that time.
Mm.
But the cost, the billing was very
Mm.
huge. Within a week it was 25K or 27K,
Wow.
right?
Okay.
And our CEO told us that this is huge. What are you doing? Or how many data you're generating? So
Mm-hmm.
we need to move that
Mm.
to our local server, right?
Mm.
And that's how the edge is, right?
Mm-hmm.
So now we were testing in Pune at
Mm-hmm.
that time. The device generates every second it sends not every second, I think in 10 seconds it sends a TCP packet
Mm-hmm.
with a location information and all other related bus information and other things.
Yeah.
We used to process that within our office on a single server that
Mm-hmm.
that we deploy. It was, I think, that time it was Ubuntu 14.4,
Mm.
uh, Ubuntu server that we've used, right?
Yeah.
And then when we tested it properly, we had everything installed. We had to move that to Dubai, right? Because the school was in Dubai, Names
Mm-hmm.
International School, right? So we sent a guy over there. He We had to buy a flight ticket for him.
Mm.
He was staying there for a month so that he can install those devices on that specific
Mm.
buses, and then configure them properly, and then test it, right? So it was a lot of cost involved at that
Yeah.
time, right? Now, if you think about in 2023, it will be a lot easier,
Yeah.
right?
Yeah.
What you really need to do is all of those installation and everything can be just done very easily. Just you plug that hardware device simply to the plug, and everything that provisioning of the device, configuring of the device can be handled through centralized management,
Yeah.
right? So it becomes a norm in industry of edge computing that if you want to install, configure, provision, and manage these devices, you have to build a single management
Yeah.
plane through which you can control these devices, through which you can configure these devices. So any firmware update, any OS upgrade, Kubernetes cluster upgrade, application upgrade,
Yeah.
can be handled through a centralized management plane.
Yeah.
So
So there is the
yeah,
device, obviously, which
yeah,
you could say that even sensors, right? If you have
yep,
cameras, if you have temperature
yep,
sensors and whatnot, especially in a factory environment or a manufacturing
right,
environment or a retail environment for that matter, they've got all kinds of
yep,
quote unquote devices. In a retail environment, you might have a point of sale terminal, right?
that's
Et
correct.
cetera, et cetera. Now, all of those, you were saying earlier that you kind of moved to Ubuntu Linux server instead of going to
Yep,
the cloud. Now, you also have to go configure, install, provision and deploy on that server. And that server is not
right,
in one place, I would assume.
right.
In
That's
your
correct.
case, the example you gave was very interesting. This whole bus example. But was that one server in one location, or was that distributed as well?
So that time it was only one,
Okay.
but I'm assuming that now it has been, installed in multiple
Yeah.
schools, and it is now tracking almost
Okay.
more than 40,000 buses.
Okay.
So it cannot be handled by a
Yeah.
single
So
server,
this
and
is the
it is,
next order of challenge, right? So there's
yeah,
one thing to talk about getting the sensors and the edge, the far. I call it the far edge. The far
right,
edge is basically where your end sensors, small devices exist, and then
yep,
obviously that data that is being processed there locally needs to
mhm,
be sent somewhere else for further
right,
processing or analytics or
yep,
database storage or whatever it is that you want to do with that data. And that can either go to a data center, it can go to a public cloud, it can go to a region locally, wherever, right? Now you're
right,
dealing with
right,
multiple these smaller server locations, right? So you have the same
right,
issue you just mentioned, right? How do I manage centrally all of these different devices?
yep,
Correct. Yeah.
yep.
So let's
So
talk about what's happening today, right? So we have this problem that was the whole management of all of this distributed infrastructure across
right,
multiple locations. And you
yep,
mentioned that there is a way to centrally manage all of this.
yep,
Let's
right.
talk about what that is. What does that look like today in 2023?
Yeah. So I think there is a concept called zero touch provisioning,
Hmm.
which, so if you have a hardware device and you want to install it in retail store, maybe in the factory or somewhere else, right? Right now in 2023, you don't have to actually send a person to configure that
Hmm.
device. All you have to do is call as a zero touch provisioning, where you just, power on the device. It will automatically connect to the local network, download the OS image, and then connect to the management plane, and then install and configure that everything, right? So if I go deeper into this, it's basically there are two concepts which are getting popular. One is cloud based provisioning,
Hmm.
with, I think there are a lot of companies which are building it. One of the examples that I personally worked on when I was in VMware
Hmm.
is Zededa, right? So what they have built a cloud provisioning management plane,
Hmm.
where you can actually onboard the devices, install operating system on top of that device, and configure that through a centralized management plane, right?
Hmm.
So the process, how it works is basically you have a device, you actually configure, you connect it to the power source, turn it on. That means you don't have to even press a button to turn it on, right?
Hmm.
That's why it's called zero touch provisioning,
Hmm.
right?
Okay.
And then you connect it to the local network,
Hmm.
right?
Hmm.
And then through that local network, it uses a technique called Pixie boot,
Hmm.
right? Pre-boot execution environment. What it does is it sends a DHCP request to your local network and obtain an IP address, and then it actually contacts a Pixie boot server, which will have a detail about your operating system, your OS images, your configuration files, your Kubernetes cluster configurations. All of those are defined in a Pixie boot server,
Hmm.
right? So this device will use a Pixie boot technique to connect to this Pixie boot server. The Pixie boot server will send the configuration file to this device. The device will identify, okay, this is the image that I have to download from a centralized management plane,
Hmm.
right? So all of these operating system configuration file and everything will be on the management plane. Once this device connect to this Pixie boot server, it will request those images. Then the bootloader will be sent to this device.
Hmm.
Then bootloader will start booting, and then it will try to find out whether it has this operating system on the disk or not. If it is not, it will boot it from network,
Hmm.
right? So operating system is booted. Once that is done, it also has a small agent which actually has all the configuration details with it, which will connect to your management plane, right? Management cluster,
Hmm.
right? and then it will send that, okay, I want a specific version of Kubernetes to be installed on my newly booted operating system. So it can be anything,
Hmm.
right? It can be anything like Ubuntu, it can be maybe Photon OS, or Eve operating system, which is basically used by Zdata, right?
Hmm.
So then once this agent will request to management plane that I want this operating system version, it automatically download that, configure it on the machine, and then it deploys all the OS images, cluster images, and everything on that device, and then it boots, and it will connect back to your management cluster and shows that this device is onboarded. And now you can deploy application on top of it, or you can just upgrade it to a latest version of Kubernetes, or you can maybe update a security patch on that device, so you don't have to actually go to that physical location
Mm.
to identify, repair, or maintain these devices. Everything can be done through zero touch provisioning,
Mm.
and all these configurations are loaded into the device automatically through Pixie boot
Yeah.
technique.
So very interesting. So you could send a device. And when you say device, it's probably a server in this case, right?
Yeah, that's
It's a
correct, that's
server.
correct.
It's a server device, a server
Right,
computer. And
right.
let's take the example of a retail store, right? You don't
Sure.
need to send a technical person to the store. You could maybe just
Yeah.
ship this device, this server, to the store, and whoever
Right.
is there, in this case, let's say a barista, a coffee person, all he needs to do is
Hmm.
to just plug it into the power
Yes, correct.
socket
That's
and
correct.
plug in the networking cable, and that's it, right? Basically,
Yep.
the thing
Yep.
will boot up on its own. It'll do all the handshake with the management server. It'll bring in,
Right.
so it's bare metal from the bare metal up,
Yep. That's correct.
bringing up the
That's correct.
entire application. So in this case, if it's a point of sale or it's some other application that's running in the store, maybe order processing, maybe some supply chain software, whatever it
Right.
is, does it
Right.
bring in
Right.
all the application packages too, or is it just the operating system and the system software? What can it do?
Right. So the process starts with a small host agent, I would say.
Hmm.
That host agent will have all those information that needs to be downloaded
Yeah.
from management plane, right? So it depends.
Yeah.
If it is a bare metal server, a small hardware device that can be considered a server,
Hmm.
right? It doesn't have operating system, it doesn't have Kubernetes cluster, it doesn't have application on top
Yeah.
of it, right?
Hmm.
So in that case, it will actually request, first it will request a bootloader, which will boot the hardware device,
Hmm.
that bare metal server, right? Once it is booted, it will load the operating system from network.
Hmm.
It will install that operating system, configure all the
Hmm.
dependencies which needs to be there for running Kubernetes cluster, and then it will actually request a Kubernetes cluster from the management plane, right? And then it can install that Kubernetes cluster through bare metal provisioning. So if you talk about platform 9, we have a product called SMCP, right, or Edge Cloud.
Hmm.
We use Metal Cube or a Metal 3 with Ironic, right?
Hmm.
That helps you configure this entire configuration into a simple CRD, right? And then through that CRD, all these Pixie boot, OS images, Kubernetes cluster version, and then all the configurations file can be downloaded to this bare metal server,
Hmm. Hmm.
right?
Hmm.
And then once that is booted, the cluster is up. It will show you in your management cluster that the cluster is up and running. The server, the edge server, is actually up and running, and now you can deploy application on top of it. And it's not just a single
Yeah.
device. If the retail store has a lot of branches,
Yeah.
right? If you consider Walmart,
Yeah.
or similar to that, we have DMart in India,
Hmm.
right?
Hmm.
So there are a lot of, even in Pune,
Yeah.
there are a lot of DMart stores here.
Yeah.
In US, it's Walmart, so it's kind
Hmm.
of equivalent.
Hmm.
And if they want to process this point of sale
Hmm.
data, they might have some hardware devices, and they don't actually need IT guy, right? They don't
Hmm.
need any person to process or manage that devices. All they just need, like you said, right?
Yeah.
Just power on, everything will be configured and installed on that devices, and it can be managed through a centralized
Got
management
it.
plane.
Got it.
So multiple
Yeah.
locations, multiple places, multiple hardware devices, you don't even need any person
Yeah.
to be there. If something goes wrong,
Hmm.
you don't need to send a person, right? You
Yeah.
can directly track that through the single management
Yeah.
plane, where you can monitor that
Yeah.
device, send an update, and patch,
Yeah.
everything can
So
be
that's
configured on
interesting. So
this.
we talked about day zero, what I call day zero, which is the initial provisioning. You
Yep.
send the device to the location, remote location. It gets itself updated, ready to go, onboarded. All the applications are running. Day zero is done. Everything's up and running. No need to send anybody. Great.
right.
Now that's just the beginning, right? So I'm sure you know how this is. Then you have the long cycle of, hey, I need to update this thing. Something went wrong with the server. The disk is full. The network connection has gone down. All of this stuff happens day one, day
Yeah.
two, operations, maintenance,
Mhm.
updates. So talk
Right.
about what happens. And you were just about to touch on it, right? So you said remote
Right.
monitoring. what is
Right.
what is being monitored, and how do things get fixed, when something goes wrong?
Yeah. Yeah. So what happens is when this cluster is up and running,
Mhm.
it is already connected to management plane. We also need to install a monitoring, I would say, monitoring operator or monitoring plugin
Mhm.
on these clusters, so that it will measure the health of these devices.
Yeah.
Right? And there are different techniques to identify the hardware level problem, the hardware level issues, the operating system level, the node level problem. All of these can be
Mhm.
detected through monitoring solutions.
Mhm.
So what this monitoring solution will do, it will send a metrics to a management plane where all of these metrics are tracked and placed at a centralized location, which can be analyzed to identify any problem, any issues
Mm.
in that edge
Yeah.
device, right? And then, for example, if cluster goes down,
Yeah.
right, and you cannot send a person to that location,
Right.
you have to do it through centralized management.
Mhm.
So through that monitoring solution, you can track, okay, this specific edge node or edge server is down.
Mhm.
What do I need to do to make it up and running again, right?
Mhm.
So you can control that centrally through a single management plane. All you have to do is just go to that specific node logs, see what happens, what is the issue, why it's getting crashed, or any problem in that specific edge node. And then you can apply the new patch on top of it, or redeploy the same version on that hardware devices
Mhm.
connected through that management plane, because the edge node is still connected. So basically what happens is, if you buy any devices, even on your router, you can see in the background there is a serial number,
Mhm.
there's a MAC address, and for some routers it's IP address,
Yeah.
right? So all of these hardware manufacturers provide a basic metadata
Mhm.
like serial number, MAC address, IP address to any specific
Mhm.
devices. So even if that node is down, right, you still have that node connected to your management plane,
Mhm.
right? And all of these metadata informations are already available. So that means you can still redeploy
Mm.
the entire Kubernetes cluster on top of that edge node,
Right.
right?
Mhm.
But that needs a monitoring solution
Right.
so that you can actually know what's the problem, what's the issue,
So
right?
this data about the health of the edge device or
Mhm.
server, is that being sent back on a regular basis to your central management system, where you're analyzing what's happening, generating alerts and health conditions? Is that what's going on in this case, like continuous monitoring, remote monitoring?
Yeah, yeah. So there are two
Yeah.
cases. One is an environment which is always connected to internet, right?
Yeah.
And there is an environment where which is air gapped. So
Hmm.
the air gapped environment is something which is not connected to
Yeah.
internet. All the application, all the device related boarding and cluster
Hmm.
will not be connected to the internet, and it can be managed internally
Yeah.
through that.
Yeah.
And this air gap environment is used in the secure
Right.
locations
Right.
where your data is very secure. You don't want it to be connected to the internet,
Hmm.
because then you will expose to the risk of hacking or
Yeah.
attack,
Yeah.
right?
Yeah.
Phishing. So
Well, in that
anything can
case,
happen, right?
in the case of the air gap solution, you don't get all the advantages of this remote provisioning you talked about earlier. You still have to send a person in that particular case. Is that correct?
So there are two
Yeah.
things in
Yeah.
that. One is, if your air gap environment is very restricted,
Hmm.
sometimes you have to send a person,
Yeah.
right?
Hmm.
But then there is another concept called, like, you can set up a local registry,
Mm.
right? Once that device is connected, you have to connect it for a smaller period of time
Yeah.
until that device is booted,
Yeah.
and then provision.
Hmm.
Once the provisioning process is done,
Hmm.
you can just disconnect and again go to the air gapped environment,
I
right?
see.
So that
Mm. Mm.
happens through setting up a local registry on that specific environment,
Mm.
right? And that local registry will have all the information like OS images, Kubernetes clusters, other configuration files, other dependencies that you need,
Mhm.
right?
Mhm.
And then it can be synced on a regular basis or maybe on a certain interval, right?
Mhm.
So you still have to connect it to the internet for a certain
At
period
some
of
point,
time.
yeah, that was
Yeah,
what I was going to ask you. In some cases, I guess it depends on the
yeah,
situation, the security situation, and
right,
how much they want to keep their equipment off the internet. But in some
right.
cases, some customers or some clients might be okay to connect it on a temporary basis to get updates and
That's
so
right.
on. So I get that.
That's right.
Now, what happens? So the flip side of that is, let's say you're still connected, everything's fine, everything's running,
Mhm.
but if you're thinking about really remote locations with poor
Mhm.
internet connectivity, right, which happens a
Right,
lot, especially if you're thinking about, let's even take the coffee shop example. If it's sitting in some remote location and Wi-Fi is not great or internet is not great, then you're going to lose connectivity once in a while, I would
right.
assume. What happens in that situation? Is it
So
still
so
is it still running? Are the workloads still running, or do they get affected?
no, I don't think so. In the air gap environment, it will get affected
Hmm.
because all the dependencies that we need to, get application up and running is already there on the device,
Okay,
or
got it.
maybe on the,
Hmm.
a secure location,
Hmm.
right? And those images are always present on that location or that specific hardware
I
device,
see.
right?
Okay.
So every time it, get crashed
Hmm.
or anything wrong happen, it
Hmm.
will automatically fetch those from local registry or from a local server,
Yeah.
right? So in that case, it will automatically reprovision and done all the things for you.
Yeah.
You don't need to be, connected to that.
Hmm.
And that is one of the core thing, because if you are in an air gap environment and if you don't have those dependencies available on that specific hardware,
Yeah.
then your application might get crash and there will be a downtime and there will be
Yeah.
problem. So
Yeah.
it's always good to have these local dependencies installed somewhere
Right.
on
Right. Right.
devices.
So
Yeah.
let's talk a little bit more about connectivity outside of the edge. Now, I would
Mhm.
assume, and tell me if I'm wrong here, is edge does
Mhm.
not stand alone. You have to connect somewhere, right? Other than
Right.
the remote management plane, which is fine, which is where
Yeah.
you're monitoring and managing all of this stuff. But I would assume it's connected to a data center, it's connected to a RAN location, it's connected to a public cloud, and it's kind
Right.
of
Right.
distributed, and edge is not on its own, right? Now,
That's
all of
correct.
a sudden,
That's
you're
correct.
talking about managing, maybe you have an AWS instance where you're sending this data to, and then you're managing that. Does this central management plane that you're talking about also manage these other data center cloud locations as well to make the whole operations easier?
Definitely, definitely. So what happens is when you, for example, if you come to Platform 9, right?
Mhm.
Platform 9 has centralized management plane that actually monitors multiple control plane of this distributed edge
Mhm.
environments, right? So maybe you have one data center or bare metal server in US,
Mhm.
one in China, one in India,
Yeah.
right? All of these can be managed through a centralized management plane,
Mhm.
right? And it actually manages multiple control planes of edge
Yeah.
devices, right? And that centralized management plane can actually connect to multiple edge nodes and edge
Yeah.
devices,
Yeah.
right? So in that way, still, like you said, it's still connected to a cloud in some way,
Mhm.
because you cannot leave these edge devices on a constrained location,
Right.
or somewhere which is not
Yeah.
connected to internet,
Right.
because managing those can still be a problem again. So in order to solve those problem, right, we need a centralized management plane.
Yeah.
We need a way to manage these devices from remote
Correct.
location,
Correct.
right.
Yeah.
And that's critical, because, right, even if the data is generated at the edge location, the process at the edge location, s- if the cluster is down, if there is any issue, you still have to maintain those devices, you still have to upgrade and provide patches to those
Yeah.
devices. So that's the reason it's kind of, I would say that edge is a subset of cloud.
Mm.
It's not completely separate
Right.
from cloud, right?
Exactly.
It's a subset of cloud,
Yeah.
and it has to be connected to cloud in order to persist your data, in order to have a monitoring solution across these devices,
Mm.
right? So that's the thing with edge, I
Yeah,
believe.
no, this is great. I mean, great conversation here, Samshir. Clearly, you understand the space. You've done real stuff. So I'm hoping that the audience is getting some real value out of this and learning stuff,
Sure.
which is great. I think there is a one important and final kind of topic we need to talk about, and I'm pretty
Okay.
sure this comes up in many conversations, which is security and reliability of the data at the edge, right? So you are generating potentially private information, especially if you're doing transactions and stuff, right? Personally identifiable information, confidential information, and you're storing it at the edge, or you're sending it
Right.
to wherever central location. How do you manage the security of all of this, right? Security of the edge solution, security of the data, and ultimately making sure that it's not being tampered with.
Right, right, right. So I think recently Intel and Spectro Cloud launched a framework
Hmm.
for securing the entire edge applications called SENA,
Mm.
right? Secure Edge Architecture, right?
Hmm.
Or I think it's I don't remember the exact name, I forget,
Okay.
but it's basically secure edge access architecture,
Mm.
right? Network architecture, access
Okay.
architecture. So what it does, it defines a set of rules to actually secure your devices on the edge, right? So starting from zero touch provisioning, and this entire architecture is built on the principle of zero trust principle, right? So this zero trust principle is you don't have to trust anybody in your company, you don't have to trust anybody in your retail store
Mm.
to actually say that this guy is a trusted person and this can configure this device and everything, right?
Mm.
So that's one of the reasons it's called as a zero trust principle, where you don't actually trust anybody on your company or network.
Hmm.
Everything can be managed through hardware provisioning devices,
Mm.
right? So if you talk about this architecture, what it defines is even on the hardware device, it actually has TPM, right? So TPM is a small hardware
Hmm.
device which generates security keys to make sure that your hardware device is secure and tamper proof,
Mm.
right?
Mm.
And they actually did a collaboration with multiple companies. One of them is KairoOS,
Hmm.
and that the entire operating system is immutable, right?
Mm.
So that means
Mm.
once you install that operating system on any of these hardware devices,
Mhm.
it cannot be tampered,
Mm.
it cannot be manipulated,
Mm.
right? It's immutable and it cannot be changed, right? So that's one of the way to protect, you know
Mm.
threat threat or any of the hacking or any of the problem with
Mhm.
these hardware devices.
Mm.
Once this is configured on the device, it uses TPM, that's hardware chip, to generate this secure key, which will make sure that your device is secure 100% and
Yeah.
all the time,
You're talking
right?
about
So you,
access, right? Access to the
yeah,
device. What about data
that's correct.
itself, right? Because I'm thinking about a situation where you have the server in some remote location, physically it's sitting in some warehouse somewhere, which is,
Right,
not like a data center or a public
right,
cloud where there's full security and all of that stuff. So anybody can break in and basically take the server and walk away with it, right? What
right,
happens
right,
then? I
right.
mean, is the data all encrypted, or how is that usually handled?
That's correct. Starting from data generation
Hmm.
to sending it to any of the cloud centralized management plane,
Hmm.
the entire data is encrypted and stored on that hardware
I
device.
see.
So even
Mm.
though if the device is stolen,
Yeah.
if somebody took that
Yeah.
device, they cannot actually read that data,
That's right.
because
Hmm.
even if in the air gap environment or any of the environment
Hmm.
where this data is very critical
Yeah.
for
Yeah.
customers or organization, this cannot be stole, this cannot be
Yeah.
extracted from
Yeah.
the hardware
So it's
device,
encrypted
and
data on the disk, and it needs a key, and you can't really
right,
read it. Okay, got it.
right,
And of course, everything
right,
that's
right.
in motion, right? If you're sending data out or in, I'm
Yeah,
assuming that's all encrypted too. They're probably using
yes. So,
HTTPS or other protocols
yeah,
for
so
encrypted
there
communication.
there is a concept called mutual TLS.
Hmm.
So all of these data that is sent from hardware
Yeah.
device is sent through secure channel,
Hmm.
which is encrypted through mutual TLS, right? So even though if the data in transit,
Hmm.
it cannot be tampered, it cannot be changed, and it cannot be manipulated. So there are two different things, right? And one of the things that I talk about is TPM, right? That hardware device which encrypt all of these data on the device itself,
Hmm.
right? So the encryption is generated through that hardware module,
Yeah.
and entire data is encrypted, and it can only be decrypted through a private key or a secret key,
Got it. So
right?
this is hardware encryption, which
Yeah,
I'm assuming is much faster than software
right.
encryption, right?
That's correct, that's correct.
Great. And I'm thinking of another use case where people are doing video surveillance,
Mhm.
and all of this video data is coming in, and you're storing it locally because you don't want to send it to some far location.
Right.
And this the hardware device would encrypt it in real time and
Right.
store it on the disk, right?
That's correct. That's
Huh?
correct. Yeah.
Okay, cool. Fantastic. Great conversation, Samsher.
Yeah.
This is very useful, good explanations, technical explanations, and clearly there's a business benefit of
Right.
operation simplicity and not sending people to all these locations,
Yep.
ease of day to operations, and all of this stuff. Is there anything we missed? Are there any other topics that we should have talked about regarding this whole topic?
I don't think so. But one of the things that I want to share is there are different companies who are already, making good progress on
Hmm.
the edge environment.
Hmm.
Uh, One of them name that I mentioned is the data, and what they have is they have this management plane, right, that I was talking about. So
Hmm.
they've entirely implemented this zero touch provisioning, and they have this wonderful operating system called EOS, edge
Mm.
virtualization engine, and it's
Hmm.
secure by default, right?
I see.
So it's tamper proof. It cannot be, you cannot even install any dependencies on that operating system. Everything can be handled through that single management plane, right? So that's one of the way that they stand out in the market. There is another company which I think have been launched in 2021 called Namla, and they have grown really fast. They have partnered with multiple vendors, and they have built a generative AI solution which can be deployed on edge devices,
Mm.
right?
Mm.
Right,
Yeah.
and they have this centralized management plane. You just have to connect that specific hardware device to that
Yeah.
Namla platform, and then it can install and configure
So
everything
this
for you.
architecture of central management has become fairly common now.
Right.
And platform 9, as some of our audience members already know, has
Right.
actually pioneered this whole, what we used to call, would still call it that, SaaS management
Right.
plane,
That's
right?
right. That's
It's
right.
all software as a service, centrally, deployed in a cloud or data center instance, and
Right.
from there you manage all of this stuff. And of course it applies to edge.
Yep.
It applies to multiple cloud locations. It applies to multiple data centers, right? So it's becoming the architecture of choice because it's not tied to any particular cloud,
Right. Right.
public cloud location or public cloud API, if you will. So one of the things we can probably end with is this is all based on open source technologies,
That's
right?
correct. That's correct.
And which is what makes it attractive to many companies because you are not dependent on any one vendor or any one proprietary API to
Right.
do that,
Right.
right?
Right. That's good.
Great. Fantastic conversation, Samshare. We should do more of these, maybe dig into
Definitely.
a little more technical details into some of these concepts.
Sure.
And we will continue to do Cloud Native Live going forward. You can contact us or Samshare if you want more information.
Sure.
We have our State of Cloud Native landing page if you want to go up and sign up for our newsletter. You will see upcoming episodes of topics that we'll be covering in the future. So you
Right.
don't miss it out. And by the way, we are streaming live on LinkedIn, Twitter, Twitch, YouTube. So you
Yep.
can watch us on all of those channels. And we also have Apple Podcasts and Google, where the
Nice.
recording will be available afterwards. So do check us out. And we look forward to seeing you again in a future episode and continue to
Sure.
have these meaningful and really in depth conversations about what's happening in edge infrastructure management and in
Sure.
cloud and in SaaS.
Right.
So, with
Yeah.
that, thank you, Samsher. Thanks for joining us today. And let's have a few more of these in the upcoming
Sure.
weeks and months.
Definitely. Definitely. I love to do
Take
that.
care and have a great day and great evening,
Thank you. Thank you so
everyone.
much. Bye bye.